The Sporland division of Parker Hannifin proudly sponsors the Advanced Refrigeration Podcast. There are a lot of questions surrounding the transition to A2L refrigerants and a lot of talking heads disseminating nebulous answers. But when your technician is face-to-face with the first A2L transition project, where do you turn for real-world answers about this specific job? Parker Sporland's Virtual Engineer is an innovative online design tool to size and select the correct components for climate control and refrigeration applications. Get your A2L system flow and component selection answers in 3 simple steps. Enter your application details, size, and select products, then download your project files. It's that easy. Try it at absolutely no cost. Visit sporlin.com and navigate to the Resource Center. Parker Sporland, leading the charge.
Oh no, you can hear it. You can hear it. We got up to a certain pressure. Like if you can hear the spraying start relieving at that point.
Idiot.
What? Yo, you've done it before at HFC all the time. Have you not?
No, because I haven't put those ball valves on HFC.
No, I'm talking about on regular HFC. You've tried to. If you can't say you haven't because you know you have.
Yeah, the Amazons. You just throttle back the ball valve, and all of a sudden.
Well, that's what I was trying to do. I was trying to throttle back the ball valve, and that's what I found out because no one's ever asked me in any of the trainings I've ever been at. I think it's maybe one. And they're like, "What's the pressure rating at which the Sporland self-checking check valve ball valve combination actually relieves?" I'm like, I can full-heartedly say I'm pretty sure it's 25, because I had a case at a Target that someone was trying to diagnose, and we were trying to figure out if the expansion valve was undersized, or it just wasn't feeding at all, or something. I was like, right now you're running. It was a low temp suction, but it had a case on it that needed to be medium temp at that point in time. And so I was like, what do we do? We could try to raise the SST by closing off the ball valve. And he's like, that didn't work. I'm like, what happened? He's like, close it off, and about 25 pounds heavier than the suction, it started rattling off and going back down. Bless you.
Oh, shoot. Yeah, no, that's not good for that.
Just saying, we were trying to do a science experiment, and the science experiment didn't work because the check valve. But hey, now we know about where the pressure relief goes. What's your good?
What's that? Sorry, allergies are terrible.
I know. I feel you. I feel the same way. No, I just said bless you. So I said bless you.
So what are you doing this week?
What am I doing this week? I think I'm at home. Yeah, I'm at home. Haven't died. Still at home. Yeah, what am I? No, I'm not leaving. I'm leaving for Boston the week following, I think.
I've been in Michigan for this is my 3rd week coming up, but this is one of the first startups in a long time where I've actually got to dictate how everything is gone and how everything is going to go for the most part, because I'm here. I got here 2 weeks early. So it's nice. And I get to walk into a job site tomorrow that is ready to go, or on Monday, and is ready to dump CO2 in. So that is a first.
We're going to talk about that in a second because I got questions. I want to hear about some stuff. But first, good morning, everybody. Welcome to Advanced Refrigeration Podcast. You're the host, Brett Wetzel and Kevin Compass. So tell me about how this is going.
This is my first Danfoss store, so this has been a learning experience. Now, we've done a metric ton of Danfoss stuff, just no CO2 with case controllers. So this was a huge learning experience, but at the same time, a huge frustration. I'll admit, that app is nice for Danfoss as long as the OEMs actually program the cases.
What do you mean?
Like, they were supposed to program all the cases, and you're supposed to pull back everything from the case in the Danfoss. Kind of like the SC3 or the CC200, everything is supposed to be pre-programmed for the manufacturer. Nothing's right.
Oh, no.
So I didn't know this when we did our initial checks, and when we were bringing everything online and we were verifying sensors. So I had to go back and verify the term sensor and the return air sensor. For some reason, on these Danfoss setups, they all have return air also. So
I think it's part of their algorithm for their adaptive defrost, if I'm not mistaken.
it is. I had to go back and figure out all those, which was a real pain in the ass. But it also was a real pain in the ass was the transistor cables that on all the walk-ins where half of them were blue was the signal and brown was the ground, and then half of them brown was the signal and blue was the ground.
Different manufacturers did different things.
No, it was the same cable. It was the Danfoss transistor, but it was internally on the cable pins. It was wrong. That picture I sent you where I had it cut open was different than the other ones were.
I was wondering what that picture was because it looked like someone like gnawed it off. You actually physically cut it away?
I cut it away. I cut away the molding on it so I could look at it and see because it was wrong. And when I flipped it, it started working, but it shouldn't have worked like that. And I cut it open and sure as shit, like I had 4 extra cables and they were all wired that way. So I don't know if they had a run of cables or they got flipped. I know with Parker, we had that. They changed cable manufacturers during COVID, and there was a couple of them where like red was no longer power. It was black was power, and it really threw everybody for a loop. And if you threw away the little paper that came in the bag, you were screwed because there wasn't much documentation on it until you figured it out. But like most of the OEMs threw away the paper in the bag and wired all the transistors red, black, green, or red, black, white.
Cool. I'm looking for something right now while you're talking.
No, that was a real learning experience. But other than that, the Danfoss app works pretty good. It is just slower than sin on the 880.
It's a lot faster to program it through the phone.
Dude, it's just slow because it's just one rack has 120 case controllers, so it's a lot. A rescan takes a day and a half.
Really that long? Day and a half?
It's like 25, 30 minutes to do a rescan.
Hey, is it on the Modbus? You can select the range. One of them you can select the range, so you don't have to keep searching for it because it'll keep going like after that. You know what I mean?
So that'd be fine if it didn't have to go through all that and then have to look through all the Modbus controllers because I have a bunch of Modbus controllers for the dual temp cases. So that's
everything's Modbus.
Yeah, but these
controllers are all Modbus.
Correct.
So can you just I think you can select the range on there, can you?
No, you can't. It goes through, but it goes through all the types. It goes through the case controllers, then it goes through looking for MXCs of all that range, and then it goes through looking for everything else. The other thing, I had a bunch of cases that were single case controllers, and there's multi-case controllers. I had a bunch of single case controllers that I could not get online. They would say they were online. It would scan them in on that number, but it would say offline in the 880 application, and then everything would read 32 degrees. Then I figured out that they had actually programmed them as 3-coil. So you had to look at the suffix at the end when it scans in. It's scanned in as a 19, not a 17. So 17 is a single case controller. A 19 is a dual case controller. So it would come online in the node status, but it would say offline in the actual application.
So what's the 3-coil then? What number would 3-coil be?
It's a 19. There's the 2-coil and a 3-coil are the same case controller. You're just not utilizing the other valve.
Oh, okay. So they were still using a 3-type controller, but you had it programmed as a single controller.
So it was programmed as a 3, but it was a single. So they did this on every end cap. So every end cap was a single. So this took me a bit to figure out as I'm going through it. I'm like, what the hell is going on? These won't come online. I swapped one of them to a 3 controller, not realizing it. I pulled it out of a dead case and it came online. I'm like, oh, hold on here. I'm wired. I'm like, this is a 3 controller. This isn't going to work. And the kid goes, hey, it's online. And I'm like, uh-oh.
So they look almost identical.
They look exactly identical, except it's a little bit longer. And instead of it goes S1, S2, S1, S2, S1, S2, or I'm sorry, S2, S3, I think it is for discharge air and suction temp across the top.
Yeah, and those the DOs for the SSR valves, they're a lot
spread. They're more spread out.
Yeah, there's no. If you notice, like on this controller, this is the 3-coil, right? You can see at the bottom. You can see the ones in white at the bottom here. Those are the ones for the valves. Or that one up there, that's only a single, and that only has one lid off there.
Yeah, no, it's you got to really pay attention when you're doing them. But yeah, this was all programmed by somebody else. So one OEM programmed the cases, Danfoss programmed some of it, and then Hussman programmed everything else. So it was it's too many OEMs involved with the programming. But other than that,
so you're ready to start up? Like you already did all the rack stuff?
Yeah, it's ready to go. As soon as we get the guts for one of the dryer shells, we're ready to go. What is it? I tried my new oil pump, and it was phenomenal. So I ended up buying a Chinese hydraulic pump for like a mini log splitter. I don't know what logs you'd be splitting with this thing because it's tiny, but it worked phenomenal.
It's probably like the one I had up in Connecticut. There was that one teeny tiny log splitter that wasn't that big. That pump, the hydraulic pump on there wasn't that big.
It's about yay big. It's got a 1/2-inch shaft on it. So it fits just in a Milwaukee 18-volt drill. So I ended up taking that and running it in the drill, and I put a check valve on the outlet and a ball valve in case I needed it.
Hold on. I just want to make sure. Greg, did you hear that?
Yeah.
Check valve goes on the outlet.
You're so mean to him.
No, but like he was asking the questions. Where does the check valve go? Where do you think it goes on the pipes?
Stop it. Ugh. This is Brett's apprentice, so we can make fun of him. So
where does the check valve go, Dad?
So I ended up using this pump. I got to come up with a better inlet for it. We used a piece of 3/8 copper on a compression fitting, and that was no good. It was kind of hard to control. So
the inlet,
yeah. So on the inlet to the pump, I was just using that. We just made it so it was big enough to fit in the actual jug, but I'm gonna have to put a 1/2-inch in there or something bigger. Because here's once the torque, it builds up some fucking torque when it goes against pressure. So at first, I primed it and it primed right away. It almost threw the oil jug. So
the drill almost threw the oil jug?
Yes. So I ended up putting on the T handle for the drill and and then we took a piece of 3/8 rod because there's a flange on there. I had one of the fitters take a piece of 3/8 rod and we locked it against the T handle on the drill. So it couldn't spin the pump on us. Because it tried to. I was pushing at least 1,200-1,300 pounds on this because I had the oil valve off and I was using it to push into the compressors. So I was pushing in against all the oil pressure and I was pushing into the high pressure oil system into the compressors. So I could physically made sure they filled before we had any issues. But it would drain a gallon of oil in 35 to 40 seconds. A gallon of oil, of thicker oil, it was cold too. So it would probably take a good 10 minutes to get it in by hand.
We would move the Solstice pretty good then. Solstice 170.
Oh, yeah. But here's the other thing. So, okay, the low pressure systems where you got to blow down the tanks and put the oil in the middle of summer, dude, you're running out of oil in 10 minutes.
Yeah.
So this right here, you don't got to blow anything down. You just hook it up and let her go. Unless you put the check valve going the wrong way, Greg.
You say I'm the mean one. What? Oh, shit. No, so you said you had it hooked up to the compressors and you were putting how much pressure into there?
Not into the compressors, on the oil tank and line.
The reservoir?
Yeah. So it's a KW rack with a high pressure oil reservoir where it's piped in as a expansion tank, basically.
Okay.
There's no drain solenoid. So it's a high pressure oil system.
No, that's fine. That's probably the one that I saw, because on the original P&ID diagram, that's what I saw, where it looked like it had, like, the oil separator is in parallel with an oil reservoir.
Yeah. It's basically like a expansion tank at that point. So so it's high pressure. So you're able to push it in high pressure and build it up. So it had those tech labs, which those take a little getting used to.
I'm waiting. So one of the guys that I'm dealing with is getting me the dongle for that. We had him on that Danfoss trainer that we had, and
I hated the fill times on this thing. So I don't know. It took forever to get
you
oil.
can adjust them. You can adjust them.
You can adjust them, but like for the settings it had, dude, it took me a half an hour to get all the compressors filled because of how slow it injects. Because it goes for a little bit and then stops, a little bit and stops, a little bit and stops. And the sight glass is offset from the Copeland one. The Copeland one's down lower. This one's up higher, and it like drains down, stops, drains down, stops. It just took forever to get all the oil in. If that was OMC's, I would have been done in 2 minutes. I would have cycled them twice with that much pressure in there. They would have filled up and been done.
But that's the reason why. That's why I think you should be able to actually mess with not every single freaking setting in there, but like the fill times and stuff. Because if you have two compressors next to each other, right? Same compressor, one's a low temp, one's a medium temp. Obviously, the medium temp is going to fill up slower than the low temp, right? No,
yeah, 100%.
I'm sorry.
Yeah, the medium temp's going to fill up slower than the low temp. The
low temp's faster because you have a higher differential.
On the low temp, you do.
Yes,
you said it right. You said it right the first time.
Yeah, I did. Yeah.
Yeah, no, 100%. The low temp needs less of a pulse, but like the medium temp needs a longer one. But I want less adjustability. You should be able. You don't need everything the Crewan has. It's too much. You don't need to be tuning PIDs on oil flows. It's ridiculous.
No, but if you have that, we were talking about before, that's why I think we have more issues with too high a level in the systems that we have now. Because most of the floats, they do 50% or 40%, and that's it. Like
I don't understand why they fill up so damn high. Like, even the OMCs, they fill up to full sight glass. Like, I get it for a scroll, but like a recip, I don't want a full sight glass. I want half a sight glass.
And even half, and Doreen's and Pitzer's both, I'm pretty sure half is too much.
Yeah, half equals broken rods.
Yeah, that's my point. So that's the problem why I think there needs to be some adjustability, because the amount of pulsings have to accommodate for how much differential and pressure you have.
Also, you need to make it so a guy replacing an oil control doesn't need a laptop and 14 different dongles and a PhD from MIT to set an oil control.
You really get a lot for a PhD at MIT, though.
Stop it.
I was asking. You said MIT for a reason. I'm just saying, like, I get it, and that one thing that sucks. Okay, so now I've been waiting on this Tech Lab dongle for a month. But if you're gonna be the manufacturer and you're gonna supply the stuff, then you need to supply the thing able to do the service on it. No,
that is gonna disappear. The first person that comes there is going to take that.
You don't need this. I need this.
Yeah, because that's me.
I was going to say it, but I let you say it. I don't need that. I got 3 others in my truck.
Yeah, but then you don't want to walk down to the truck. No, you got 4.
And then we tried that when we got our first set of core links at one of the stores.
That was gone instantly. Everybody the same thing.
Because I was like, we can lock it up in this one cabinet. Gone. Who had it last? I don't know.
But the Corling thing is stupid though, because you could build your own that was better than that one for way less.
I know. I'm just saying. It's one of those things where it's just gone.
Like the CO2 leak detectors. We tried that. We tried locking them up at the store in a cabinet, and everybody was just taking them and putting them on their van.
I can do a lot more damage with this not sitting on the job site, being in the truck.
All right, so what are we talking about? We're going to talk about generalized charging and...
I don't know, get ready to piss some people off then.
All right, let's go.
Oh God. Okay, let me preface by saying these are our opinions and not the standard practice of all the manufacturers. Let me start off by saying that. I should have grabbed the sketch.
God damn it. Here we go again. Okay. We're going to talk about charging CO2, and 90% of the manufacturers want you to do it one way because they have always done it this way because we live in the boomer mentality.
I think it's just that. I think it's, they don't want you to trap anything. Like, they know how they manufacture it, right? They don't know how cases were piped. They don't know if they put the wrong piping in there.
So everybody wants you to charge into the flash tank, okay, for initial startup, okay? This is where it gets to be a nightmare for me, and it just sends me off of the hedge. So everybody wants you to charge into the flash tank on initial Shut up. Okay, so everybody wants you to charge into the flash tank, and here's where I disagree with it. So if you're charging into the flash tank and you're pretty much at operating pressures and you're starting to run and you're putting gas in, did you put Mr. Positive at the bottom? Fuck you.
You just saw that now?
As you're going through and you're dumping this gas in, it's at 500 pounds. Okay. If it's generalized temp, like in a store, like 60, 70 degrees, you may only have 700, 800 pounds, maybe 950 in the tanks. Okay. So you have till you equalize out to 500 pounds to get that liquid out. So the lower the tank pressure is, the less liquid you're getting out of the tanks before you spit out. I have found that I'm losing 20% of the tank charge at a minimum.
Today's episode is sponsored by the RefRuShield RDP Series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP Series differential pressure monitors, including the new transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales@westermeyerin.com. That's WESTERMEYERIN.com.
By charging to 500 pounds in the flash tank. So 20% of those tanks, and that's if you don't slam the flash gas bypass valve all the way open and lower the tank pressure down to suction. And you can only do that if you have a high pressure oil system or if you're paying attention to your oil levels. So to get more gas in there out of every tank. So if you're doing this, you're wasting all these tanks. So I'm finding tanks that are 25, 30%, some of them even 40% full. By the time if it's wintertime and the tanks have been outside in a construction site, like, you're screwed. If you don't bring them in and you got no heat in the building, like, you're going to get 50% out of the tanks. Now, this is the way I do it. And I'm just going to preference this. This is not the way all the OEMs show you, but this is no different than a DX rack. How do we charge a DX rack? We shut the receiver ball valve. We charge to the dryer cores, and we fill it through the cases.
I thought you were going to say suction for 1 millisecond. I'm like, what? I hate you.
To the suction. Brett,
no,
1,600 pounds.
No.
Brett's full of shit. He ran enough service. You can't tell me he wasn't dumping 100-pound cylinders to that nice 3/8 packed angle valve on a Friday at 3 p.m. to go home. You're a liar. There isn't a single service tech here that has not done that.
Okay, we're not going to do it for CO2 at all.
Okay. Now, dumping it down into the liquid line. So you shut the receiver ball valve and you're going through the dryer shells if it has it, or you're going through the strainer on the liquid line if it's Hill Phoenix. You got that nice ball valve right there that's 1/4 inch or 3/8. Charge it there. Let it go through the cases. Let it pull down through the low temp suction and through the medium temp suction. You're going to pull down through the low temp suction. You're going to now bring that tank to 200 pounds or 150 pounds, 190 pounds, whatever the compressor shut off at. So you're sucking that tank down to a low temp suction pressure now because it's going through the low temp compressors and it's boiling off. Here's the caveat to this. You're not going to flood back, especially if the store's warm. All that's just flashing off as soon as it hits the cases. It's flashing off in the liquid lines as it goes. So you have less of a chance of flooding out and wiping out the compressor. So it's more controlled because if you're shoving tanks down the suction or down the liquid line and you got to shut it off, you could kill the store ball valves on the suction side, watch the pressure and give yourself some more time if you need to make some adjustments or fix some issues or oil or fix something with the high pressure valve or something is wired wrong. You get a little bit more time by being able to isolate the store so you're not blowing off suction reliefs or blowing off other reliefs. So it gives you a little bit more controllability. You could stack some gas in the store as long as you're watching the pressure, and it gives you a little bit more charge and ability to adjust the charge. Now, you need to go a little slower when you charge. Like you don't want to just hammer down 60 tanks in there because it's going to take a few minutes for it to come back.
I think that's the reason why they want you to fill it, because like normally they want you to charge by the flash tank to get it up to where they want before you actually relieve. So there's a couple of different
But it's never
reasons.
close. It's never close. You always end up adding a couple 100 pounds.
Just saying.
Most of the flash tanks that I've done here lately have not been able to pump a store down.
Really?
I want to say probably half the racks I've done in the last 3 months.
You use wrong piping, or it just wasn't calculated properly?
The flash tanks is too small. So you're not able to pump it down anyway. So I would rather charge it that way. I get way more out of my liquid tanks. We're wasting all these tanks, dude, and these tanks are hard to get now.
No, I know. It's always, we were doing a startup, and the guys, he's like, are we getting another tank? I said, yeah, probably. Why? He's because if I cut into my last tank, I'm not going to have enough for a full, the site wanted a full recharge on site. I said, okay, we have other liquid available, right? It was like, you have all the other tanks that we just charged. We were just doing it by flash tank, right? They were getting a flash tank, dropping it off, and just pushing it over the next one. Because I was like, we'll come back to the other ones later. He said, yeah. I said, all right, let's charge it up. And so we did essentially what you did. But what was nice about this rack is that it actually had essentially like a header system, right? So once we got the low temp fired off, we literally just kept, we used the same charging line for the system for the tanks that were downstairs. But all we did was just hook it up to the liquid line of the low temp with it isolated, so it would pull it right down to 200 pounds, 180, whatever the hell the set point was. And that way you get all that excess CO2 out of the tank, so you're not wasting. It's 10 or 15 pounds that you're losing per tank. No? So those are 50-pound tanks. When we were weighing them, I was ending up with 25 to 27 pounds still in them charging by the flash tank. That's 50%.
Yeah. If they're cold. So if it's summertime and they're sitting outside, yeah, you may end up with 10 pounds in them. But if they're like 80 to 70 degrees and below, you're going to end up with half the tank. You can see the frost line on them. Like you can see the frost line where you lose the pressure and it stops. You'll see how much liquid is left in there. So unless you bring a turbo heater in and start tarping the tanks, get the pressure back up, they're not going to feed in.
Agreed.
So this is where it's a huge problem, and we're wasting all the CO2. So we're sending all these tanks back to air gas or wherever they're going to get vented off and recharged, and we're paying for this expensive CO2 because it ain't cheap anymore. We're paying for all this CO2 to just get blown off in the atmosphere when we could be using it. When we charge down the low temp suction into the low temp through the low temp liquid lines and into the suction through the cases, I'm averaging like 4 to 5 pounds left in the tanks.
Still, even after.
Yeah, I mean, it's 4 to 5, like a little bit of liquid vapor at the bottom.
And these dip tubes don't go all the way down the bottom either.
I would assume not. And that's the other thing. Like a lot of these older, like air gas tanks are old. Praxair tanks are old. We've been getting aluminum tanks from American Welding Gas Supply, which has been awesome. They've been rolling out 50-pound aluminum tanks. They're half the size of the steel tanks. I
half
can
the
pick
size
one.
or obviously half the weight, but half the size too.
Yeah, they're shorter. So like they're up to like my chest level.
Your sternum, okay.
Yeah, I can pick one up with one hand. That's how light they are. And they transfer heat a lot easier, so they're a lot easier to warm up.
It's not one big heat sink.
Yeah, so it's a lot easier to warm up with a turbo heater and a tarp. Because we've had to do that on construction jobs because they're outside and they're cold, you're screwed. You're not going to get any gas out of them. Especially a warm system.
And that was part of the problem that people were saying, like, when there was a real tank shortage, because it's not really a CO2 shortage, it's more along the lines of there's a tank shortage because someone has 3 charges worth of what they need on site. They end up having to order a charge. And you had those low pressure cylinders, those low pressure.
The doers?
Yeah, the ones that are only set at like 350 pounds or something like that.
Yeah, you can boost them up a little bit higher, but like, those are at 350 pounds. Down the liquid line still work.
No, 100%. Someone said to me, they're like, could you get it for? I said, you want to at least have enough that you can get at least one of the medium temps rolling, and then turn on something for the low temp, and then suck it down the liquid line with that.
Yeah, 100%. Like those doers work, and if you order those doers, they're half the price.
Oh, they really?
Yeah, they are significantly less because the delivery cost is way less. So they can boost those too. There's a way to boost those, I think, to 400 pounds.
There's like a dual relief on it or something, like almost
like
a splash for the Hill Phoenix.
Yeah, and somehow it like builds its own pressure. You can get a liquid pump, but I heard they leak like a sieve.
It's not like you're just transferring it, right? You're literally you are transferring it, but your compressor is essentially your pump. You know what I mean? You're getting that suction pressure down.
Yeah, honestly, like if I was doing a massive system like you and James were at that facility where you knocked all the tanks over.
So much.
That I would have charged it with doers. I'm never gonna let it go.
I'm not getting tanks off.
You're the only one to this day that I've ever seen break a Carnot hose.
I still have it in front of me as a daily reminder. Not the hose, but the fucking fitting. It was like, that's a chintzy piece of freaking brass right there. That's because he was on job site before, so that means he was wrenching on it. I was just like, oh, I just need a little.
You just weren't used to. There wasn't a keyboard. There was a wrench.
You're a fucking dick.
That was what he said, not me. All right, so back to it. Like, yeah, honestly, charging down the liquid line, we're using way less CO2 than we are. And that's why I'm looking at these racks and I see these ridiculous charge rates on them. And it's like that. There's no way that rack held 2,000 pounds of gas. It's not. It's probably 1,000. But like, again, they counted the tanks as 50 pounds, 50 pounds, 50 pounds. You only got 25 pounds out of each tank. So in all reality, you use half the tank on every one of them. That's why they're so heavy when you're putting them back. They still got liquid in them.
Yeah.
So charging down the liquid line to me is just more stable for what you're doing. We've been doing it that way for 50 years on DX stuff. We never charge into the receiver on DX stuff. Because then you're going to end up with a bunch of expensive tanks that are half full.
Yeah, maybe we get Dale back on here. Dale doesn't mind talking to us.
Yeah.
What?
God. And then now on to my next thing, the charging setups. I have used normal refrigeration hoses for 12 years. This is my opinion, not Brett's. I have used normal refrigeration hoses for 12 years. I have not had one single hose blow off in 12 years. I've seen braided hoses fail. Brett had.
Yeah, so have I.
because you know what I like about the normal hoses is you can't really crank on them because they only get so tight and they're gasketed. Yeah, the gaskets shit out, whatever. I have not had one fail black charging hose. But now, mind you, I'm not using shitty hoses. Like these are quality yellow jacket hoses. Like they're quality charging hoses, black charging hoses. Those have a high rating.
Well, so
and you don't trap liquid.
Yeah, so I'm okay with it. As like you can use a set of 410 gauges as long as your pressure of your tank isn't like 100 or 12 or 1,300 pounds. What really think limits it. Those that'll handle it all day long. What really limits it is the manifold itself.
I don't use a manifold. I don't use a manifold when I'm charging.
I understand that. I'm saying using refrigeration gauges that are rated for that, fine. But it's the manifold. I remember one of the manufacturers of gauges was like, "Yeah, we got CO2 gauges." I'm like, "How high they go?" He's like, "I don't know." I was like, "You need to really, before you start selling it off as CO2 gauges, you need to know that, because if some guy puts it on a TC system, and all of a sudden the system's at 1,300 pounds, and oh, what's the manifold rated for? Oh, it's only rated for 800 pounds. Boom."
Yeah. So like I personally, when charging, I use a stainless header that I made that we TIG welded up, and I can connect 6 tanks to it. If I'm just charging one tank, if I'm just putting a couple 100 pounds in and it's just going to be lickety split real quick, I use 100-foot 3/8 charging hose I make sure religiously that the gaskets get changed, and I have a stainless ball valve with a sight glass on it, but I do not trap liquid. I am not shutting off the rack end before shutting off a tank. You have to kill the tank first and let the hose drain down. If you're going to isolate it, you need to blow the hose down at least till standing pressure. If you don't trap liquid, you're fine. I don't give a shit if it's a hydraulic hose. It's going to blow too if you trap the liquid. If it's a hydraulic hose or a refrigeration hose, they're both going to blow if you trap liquid.
I got this picture from our buddy, the Newfoundlander.
Newfoundlander.
No, Newfoundlander. The guy that looks like Gary the Enticer. You know what I'm talking about? This was his rig for charging CO2. Kev, you've seen this before, yeah?
Yeah.
Then that way, he basically has his own manifold. He's got a gauge that's able to go up to, I don't know, probably 2,000, 3,000 PSI. All stainless steel fittings, and he could basically charge CO2 directly from that.
Yeah, that's too small for me, though.
No, but if as a service technician, if you're just doing 1 or 2 tanks, no harm, no foul. Right? I'm not saying you charge a whole fucking rack with that thing. I'm just saying, like, it's too small for me. No, I'm just saying.
The other thing is, I'm convinced if you bigger hose, you get more gas out before you lose liquid out before you lose the pressure.
Say it again?
With a bigger hose, I'm convinced you get more liquid out before you lose the pressure. You get more flow out of it before you lose the pressure. As soon as you lose the pressure, you're done.
Yeah, okay.
So with a bigger hose, I'm convinced you get more flow out of it and more pressure before you lose the pressure. But I use a stainless manifold. I just upgraded everything, and I ordered pressure washer hoses for everything.
You gotta show those pictures.
I'll show them next week. I ordered pressure washer hoses for everything, and
still can't believe this. Go ahead, continue.
So all of them are rated for 6,500 psi, working pressure, not max pressure, working pressure. We're never going to get anywhere close to that, ever. So you may see 1,500 psi, and that's max. You ain't charging at 1,500 psi. So I'm using pressure washer hoses, and I got Bobcat hydraulic fittings that connect to the manifold, so I could disconnect the hose without losing any pressure in it. if I need to quickly disconnect a tank. What?
Why though? Why with the quickness?
I don't know. In case you need to disconnect a tank. We've had gaskets start leaking. You need to quickly disconnect that tank. I could disconnect that tank, and now I don't have to put a cap on the manifold. I don't have to blow the whole thing down on the manifold and put a cap. Now that portion is sealed. So if I need to kill a hose to fix something on a tank that's leaking, I could just kill that hose, just disconnect the Bobcat coupling, and I'm done. So I have that, but I also had to make this work for DX charging. So I use the same charging rig. So I had to adapt the ends to where I could take the CO2 tank adapters off and screw in a 3/8 tank adapter for a 100-pound torpedo. I did get high pressure rated ball valves though. So I got DN10. I did. I got DN10 10,000 psi ball valves. But the main pressure washer hose I found was rated from -50 to 248 degrees for 6,500 psi. And it was $130. A hydraulic charging hose that these guys are getting for CO2 is like $300 to $400. And I was able to find all the ends at Menards.
Are you fucking serious?
Yeah. Every fitting I needed, I was able to get at Menards.
It looks like it. Yeah, I'm looking at it more and more now. And it's a pressure wash. Okay.
Show the picture. You can show it.
Okay. You told me not to.
I think this is going to be perfect.
So make sure I gotta save the picture before I share it. I'm just saying.
A lot of shit talking in that group text.
Oh my god.
Pretty sure right before that is just those two making fun of each other.
Oh, there was some other stuff in there too.
But no, like I think this setup's gonna be fine. Like this is now, mind you, I do a lot of startups, so
that's pretty. Did you do those welds?
My brother did.
Kevin does have a brother, by the way. I didn't know until about 3 years ago.
My brother and one of the guys at work finished it, so that's
pretty.
Yeah, so like all the takeoffs on there, so I have it all set up, and now where that sight glass is, it adapts to the pressure washer hose quick connects. So I'm able to throw all those on there with the Bobcat fittings, and
That's what these are.
Yep. So they're hydraulic 3/8 couplings.
That's basically what they use on the hydraulic stuff for the dumpsters.
Same thing. Yep.
Yeah.
Same thing. They're no loss fittings, so you can unclip one of those and lose no pressure out of both sides. And then it goes to the hydraulic hose. Then it goes to the ball valve. And then it adapts down to the sight glass. So I have sight glasses on the tank side.
What's this side right here for?
That's a sight glass built into it.
Oh, see. Oh, shit. Okay.
Yeah, I stole that from a rack, but it's useless.
And then here's your Bobcat or your ball valve with the.
No, that's part of my old charging rig. So that was my old. I took the CO2.
Oh, right here.
Yep.
These ones right here.
Yep. So then the CO2 tank adapter screw into a 3/8 male flare that screw into the sight glass. So I did it so that way I could disconnect the 3/8 male flare out of the sight glass, and then I could put in tank adapters for 3/8, so I could charge off of a 100-pound tank.
So that means you could suck down a whole. 10,
I could do 6 CO2 tanks or 6 DX or 6 like 448 tanks, torpedoes at once. And then it's adaptable, so I can go from 3/8 or 1/2 inch. So I have a 3/8 charging hose right now, but I'm going to buy a 1/2 inch one, and the outlet of the header is 1/2 inch. So I could throw half-inch in there. So it's a bunch of 3/8, pure 3/8 tubes into half-inch in outlet. So you really go quick.
Yeah, but don't these quick connections really reduce the amount of?
They're full flow.
Really?
They're full flow. It's I think it's 10 GPM per fitting, which we're not flowing that much.
So would you use the quick connector? Because I know you use this for a vacuum rake too, don't you?
I don't use the quick connects for a vacuum. I don't think this is vacuum rated. Like this is purely charging. So for vacuum, I have a completely different setup.
You have a whole nother rig. So another whole 4 pack outs that dictated for vacuuming?
No, I have 1 pack out or 2 pack outs for vacuuming.
That was close.
Yeah, 2, but like 1 setup for a vacuum kit and 1 setup for pulling racks down. What? So there's different setups. Like you need a cross with a 5-way cross for the Appian stuff or the Appian, the Blue Vac stuff. That's a made up one.
Is that a flare to flare fitting right there?
So I cannot find a flare to flare union. I've been to like 4 hardware stores this morning trying to find one.
I had to buy just the coupling union that they make.
Yeah, I can't find them. They're out of stock everywhere. So I got to go to a supply house and order them. But they're flare to flare right now. But like I just got to order a coupling. So a flare to flare union coupling.
Yeah, this is right here. Huh?
No, that was a mocked up one. It's MPT to MPT.
Okay.
But no, that's how I'm doing it. And then that gray hose is my main charging hose now.
This one right here.
Yep. It is fucking heavy.
I'm sure. How many feet is that? 100 feet?
That's 100 feet. And you can go to Menards and buy another 100 feet of the same hose basically for $140. And
you looked up the spec for that. That went all the way down to
that hose right there goes down to -50.
Yeah, it's pinprick too.
It's pinpricked.
Those are some serious ball valves. You couldn't get the high lock ones a little bit smaller. You had to go like balls out on the ball valves for those.
Dude, the high lock ones were double the price. Those were $26.
Because of the size.
They're honestly not that big. The handles are big, but
the handles are excessive. And then that's just what you putting this on the header then?
No, that's just for me for checking compressors because my other one died. So I'm using that to check high pressure switches on the TC side. So adapt it down and screw right on the compressor and then shut the thing and hope that the relief doesn't blow in your face.
No, I got you. Would you recommend at least putting a fucking gauge on here?
No, why?
Because you're not 100. I don't know. It would scare me not knowing what's going on within this side of the pipe. If I'm just relying on these and their full flow, if one gets blocked up.
What is that going to mean? Like you just shut the ball valve and take care of it.
Okay.
Yeah, I've never had a gauge on the charging line because everybody uses the gauge to tell when the tanks are empty, but that's what the sight glasses are for. So the sight glasses, as soon as you stop flowing on a tank, you know it's empty.
And you have a sight glass for every single tank.
Yes. Because they'll start to empty out before the others. So like they put it this way, there will be on Monday 2 guys swapping tanks and they will barely be able to keep up. That rack I did with 3,000 pounds of gas in it, close to it, like there was 4 of us swapping tanks. And then we had 2 lines running up with 2 more like teed in manifolds, 2 lines running upstairs that was charging into the other liquid lines. And we could barely keep up on those.
Damn, Daniel.
That is, you could buy a manifold or make one on HXP pipe. So I know a couple guys that have HXP pipe ones. They took HXP and they welded a bunch of, which is great. They have those, Superior makes those Mueller makes those 3/8 stubbed ball valves, like those like service ones where they have a 3/8 male flare in the end and a 1/4 turn ball valve. Those are great for making manifolds.
3/8 male flare and what?
So like, you've seen like the hill racks at Target have them a lot. Like where instead of service valve, they have the stubbed mini ball valves where it comes off the stub and it has a 3/8 male flare, a quarter male flare at the top. Those are great for making charging manifolds.
Yeah, I would recommend if you're gonna do it that way though, have it like churched up with some unistrut and some pipe holders because
what's wrong with mine?
No, I'm not saying no. Yours is a fucking heavy duty. What I'm saying is you don't want the thing rolling off and breaking off that ball valve there. You know what I mean? Because I've seen on racks what depending on what's on there, they crack because there's too much weight on a rack where you have the ball valve.
I will say this though, this was my limitation before, is I had 6-foot hoses. I had 6-foot 3/8 hoses coming off this thing to 3/8 taps on the header to ball valve setups, and it was a problem on the air gas tanks because they're like 5 foot tall, or 4.5 foot tall. So it was a problem because I was stretching the hoses and I kept blowing out gaskets. That's why I went to an 8-foot hose now. So each one of these branch hoses is 8 feet.
It's a huge ass ball valve, sir.
It's not that big.
The handle is huge.
You can knock somebody out with it. Yeah, it's not that. I've also shrunk it down, so it's like another 1.5 inches short, 1.5 inches, 2 inches shorter. So with the correct fittings, but as soon as I get rid of that flare by flare union, it'll lose another inch.
No, just asking for safety reasons. Is this sight glass rated for?
Oh God, no, probably not. I have yet to have one of those fail. I have probably put 50,000 pounds, 60,000 pounds.
We're going to take that away right now.
What? I have probably put 60,000 pounds of CO2 through that 3/8 Portland sight glass. The old ones are, God, they got to be 8 years old now.
I'm assuming you haven't been able to find one.
What? I haven't been able to find a high pressure sight glass, but I honestly haven't really looked because those were on my van.
44.8 bar maximum.
That's a lot.
650 pounds.
Yeah, see?
This is why I say pressure.
You just don't trap liquid. Listen, it all comes down to, as long as you aren't stupid, everything's fine.
As long as you're not stupid, everything will be fine.
Yeah.
You need to get, that's going to be on a shirt. Hold on. As long as you're not stupid, everything's going to be fine.
What? As long as you don't trap liquid, everything's fine. You with his fucking shirts, and then we're gonna watch Matt Wexler have one. He'll be the first one to buy one.
Everything will be fine. I rate slow. Sorry. I'm not gonna tagline for this episode. All
right, guys. Yep. Thanks for listening. Yeah, thanks for listening.
Bye, guys.